Hi everyone, this is Kyle Welch with SDX Central. I want to thank everyone for joining today's webinar, Managing and Securing the Sprawling Edge with SD-WAN, presented by Open Systems. For today's webinar, we're joined by Jason Bloomberg, the president at the analyst and advisory firm Intellex. Additionally, we're joined by Maritz Mann, head of product management at Open Systems. By watching today's webinar, you'll gain a broad understanding of how IoT and AI are driving innovation in edge computing. We'll also discuss how these technologies are advancing security. And finally, we'll discuss the role of SD-WAN in tackling modern enterprise network challenges. At this time, I'd now like to hand the presentation over to Jason to start the discussion around securing the edge with SD-WAN.
Well, thank you very much, Kyle. And let us advance the slide, and it should advance here. There we go. So we're talking today about the sprawling edge, managing and securing it with SD-WAN. So we should probably start this discussion with this notion of the edge. What is the edge, and what does it mean for it to be sprawling? I mean, this is sort of an odd word, sprawling. What does that mean? So when we talk about the edge or edge computing, there's actually multiple different edges, and this is one of the most confusing things about this notion of edge computing, is that it's not just one thing. So you may think of it as a traditional enterprise or corporate network. So you have your firewalls, and inside is the trusted environment, outside is the untrusted environment, and the perimeter defines the difference between the two. And then you have this notion of a perimeter, and you can think of that as an edge of your network. But today, really, that whole notion of perimeter-based security is falling by the wayside as cybersecurity challenges and networking issues and networking challenges generally break down that notion of perimeter-based security. So even though we still have firewalls and we still have the notion of a corporate perimeter, it's becoming less of the edge story over time. So what else do we mean? Well, we could mean the cloud, right? So we have our on-premises infrastructure, we have cloud-based infrastructure, and we could think of the cloud as being part of our corporate environment, right? If we're using a SaaS-based product, it's something that we're using internally, so we can think of that as being inside the edge. And what does that mean then if we include the cloud in this, inside the edge? Then, oops, somehow it advanced. Okay, there we are. So we can also think about the internet itself, and what does the internet mean for the edge? If you think about the internet is technically a network of networks, right? We have our corporate networks, and then we have the internet connecting them, and so that's breaking down this notion of the edge across the globe, right? So it's hard to say that with the internet there is anything that even qualifies as an edge. So this is part of what scratch people, makes people scratch their heads, is if you have the internet, there's really not the edge of anything if you're not talking about the corporate perimeter itself. And then we have this notion of content delivery networks, or CDNs, and really it was the origin of CDNs that really got this story of edge computing off the ground. So a CDN, Akamai is perhaps the best known, but there's quite a number of them out there now. The idea of a CDN is that it moves essentially the web servers, or the web-based processing capability, geographically closer to the consumers of those websites. So instead of, you're going to, let's say, eBay, well, eBay has, data centers, and traffic could go, every time you click a link on the eBay site, you could go all the way to an eBay data center and back. That's not very efficient. So instead, companies like eBay and really any other company running a corporate website will move those web servers to various locations around the world closer to their customers, and then those edge servers, the CDN servers, have to interact with the core servers at the company data center in order to keep the information updated. But many of the interactions don't have to make the full round trip. So it increases scalability, it lowers latency, right? Latency in terms of how long it takes to do that round trip. But it's primarily focused on websites. Now, we have mobile applications as well, and mobile applications can benefit from CDNs. So it's more than just websites today. It's really everything you want to interact with over the internet, including mobile applications. So
I would, Jason, thanks. I would add there that I think CDNs, from my point of view, represent to some extent the infrastructure-centric parameter view of the past, because CDNs represented kind of parts of the internet caching content of web servers or websites or videos, and it's still a major concept, don't get me wrong. But what they already did is, in a very early stage, is bringing applications or application content as close as possible to the end user. So whenever you had a network like 10 years ago, you want to make sure that you break out your internet for your users as closely as possible to the CDNs to serve faster. And today with Netflix, you know, everything's it's already on the edge and close to your mobile or tablet.
yeah, you bring up a good point, Moritz, that we're talking about the physical network here, right? The actual servers, the actual network devices, and the network protocols that connect, you to your ISP, to the internet, to the provider of Netflix or eBay, whoever it is. So we're at that physical level, and as a result, we have limited control. We, as in the companies providing the content, have limited control over how that content is delivered and what the various policies are that apply to that content, right? So Netflix can, put up a movie and it has certain controls over it, but there are limitations to how far this CDN model for the network can go, and that's one of the challenges that we'll be talking about today. So we have this notion then of the CDN, and we have people surfing the web and using their mobile apps, but now we have the Internet of Things as well. So instead of just handheld devices or computers interacting with websites, now we have a whole range of different kinds of technologies. So sensors, divided into sensors and actuators. So a sensor basically, it could be anything from a camera to a temperature sensor to a motion sensor, gathers information from the environment, so it turns that into a stream of data that now has to go somewhere. Then actuators actually control things, so that could be some sort of robotic control or a thermostat that changes the temperature in a room, or whatever the control is over the environment that you want. So now we have to have data go to that device in order to execute that control. These IoT devices can go anywhere. It includes all of the devices we were talking about. So it includes smartphones, includes tablets, includes your Apple Watches and everything. But in addition, all of these IoT devices that may be everything from sensors in the road as part of a smart city traffic control to a sensor in a truck that's driving down the road, or the devices that go into autonomous vehicles that enable the cloud essentially to provide some measure of control over the autonomous vehicle. All of these are part of the Internet of Things. So as the name Internet of Things would suggest, these go on the internet, although you could put them on a private network as well. But really the idea is this is an Internet of Things. It's about the things, right? Whatever the devices and actuators control or provide data on, but it's also about the internet being able to connect all of these things into this vast internet that now requires the appropriate infrastructure to support, to control, and to secure. And now that ups the game on all of those things. So for instance, we need IoT gateway. So it's not good enough to have some sensor in a truck send data all the way to the corporate headquarters. It's going to interact with some sort of gateway, which is typically a device that is located, could be at a factory, it could be in the smart city traffic control box that might you, as you see on a street light, for example, or any number of other locations. All of these devices might need IP addresses, and this is one of the reasons why we're moving from IP version 4 to version 6, is we need a vastly larger number of IP addresses than we thought we did many years ago. And it ups the management and security challenge, right? We need to manage all of these devices. We need to secure them. We need visibility into what's going on. We need to deal with the vast quantities of data that these sensors are throwing off. So this is actually now defining a new kind of edge, which we might call the device edge, right, where the devices themselves are. But we're also calling it the far edge, because we'll talk about the near edge in a moment. So this notion of the far edge now is the devices that are essentially in front of the human beings, right, the consumers or individuals holding a smartphone, say, but it's also the IoT devices that may or may not be interacting directly with people. Sometimes they are, you know, your Nest thermostat, for example, is something that you may control, but it may be, you know, a control device on a factory floor robot as well.
What we see here in practice is that this is actually happening all at the same time, and that these devices not only share the internet, but they share generally any network they can tap into. So what's happening there, it's kind of similar, comparable to the shadow IoT. So users adopting like business applications that are delivered via SaaS services. And IoT devices, they merely only need network access and they're on their network. And if you look at like myriad attacks, and especially from our point of view, the security issues connected with these devices are not to be underestimated, because management often is very hard to execute in reality. And we see that, I mean, if I could distinguish like 3 different classes, I would also say that the device edge is generally speaking industrial IoT, which is all about PLCs, IOCs, where it's really industrial operation technology. So they're usually air-gapped networks that are tending to be connected more and more to the network. But then there are like all these smaller smart devices, to put it in quotes, like video cameras and other devices, even like vending machines, point of sales activities that can be that are still on the same network. And the third piece I would see is more than really in new applications where you have smart sensors, like you said, like the thermostat, like a sensor that reports some movement or something that is relevant for the end user or the business to perform the actions. All of them have in common that they are usually unpatched, hard to patch. They're not as mature in security updates as they should be. And you have to be very careful if you put them on your same network. And you have to ask yourself, can you control actually what users and put on the same network that you're in?
Yeah, so there's really 2 sides to this challenge, right? On the one hand, there is the networking infrastructure side, right? If you have a factory and you have the various IoT sensors and controls within the factory, there's no business having that information, those controls, be accessible outside the factory. So as you say, it may be air-gapped, right? It may not be even connected to the internet. That would apply to you know, a power plant as well, that kind of, you know, critical infrastructure type technology, where, you know, the internet presents too much of a risk even to connect to the internet. But then, you know, you may want to be able to connect it to the internet, and now you have to deal with the management security as well. But more often than not, these IoT devices need connectivity to the cloud, to the corporate control by their very nature. You know, for instance, let's say you have a refrigerated truck on a freeway, and you want a sensor that is a temperature sensor to ensure that, you know, the refrigeration is at the proper temperature at all times, right? Otherwise, your ice cream's going to melt, and then, you know, you lose your you lose the value of the load. So you need, that's could be very important, not just at particular points in time, but really on a continuous basis. Well, that information now, it's not good enough just to be on the truck, right? It has to be sent to the cloud to, to alert, the company if there's a problem. So more often than not, that's the issue. But now we have challenges of like the Murray botnet, right, which is essentially a type of malware that took advantage of weaknesses primarily in consumer-oriented IoT devices. The most famous being the baby monitors, right? So you could have a baby monitor not only that can spy on your children, so the hackers can spy on your children, but actually leverage the devices as part of this botnet to mount denial of service attacks or something like this, basically taking over your baby monitors and your home routers and your Nest thermostats. I don't want to pick on Nest. It could be any thermostat. But really any of these now are vulnerable. And so we have the security challenges that in the consumer IoT space are most flagrant because consumer technology tends to be less secure than corporate technology. But even in the corporate world, because many times that security is critical infrastructure, say a power plant, then, yes, the power plants are more sensitive than baby monitors, but if it's your baby, then you may have a different opinion. So, there are many different facets to this challenge.
Yeah, especially, I mean, just getting back to the simple video surveillance camera. So most of them operate still with embedded Windows systems that may or may not be supported anymore.
Mm-hmm.
So if you have them on the same network, they get usually very quickly prone to WannaCry and the associated vulnerabilities. And it's who will update those for you and who will manage them for you. So I think this is one part of the business equation, and the other part is also industrial IoT. There's also a significant market from nation state actors or cyber activists or terrorism even that are really focusing on even if they're air gapped or semi-gapped networks to bypass controls. Think about Trices, thinking about Stuxnet, that were really frightening examples what can happen if actors hack PLCs in a power plant to manipulate valves or pressures in certain areas of the plant.
Absolutely. So we have the notion of a corporate perimeter, which was the original edge of the network. We have the CDNs defining the cloud edge. Now we have the far edge or device edge, where the smartphones and handheld devices and IoT devices live. So of course, if we have the far edge, that means we need to have the near edge. So what is the near edge, and why do we need near versus far, right? Is it important to have this distinction, or is it just needlessly confusing? And the reality is this is an important distinction. So the near edge would include, for example, those IoT gateways. So the IoT devices themselves, they may be in the trucks, they may be in the factories, they may be the baby monitors, but the IoT gateway is typically in a phone closet or a network closet that has that a measure of greater control. So where the IoT devices are out in the field, these IoT gateways have a measure of security and typically have better connectivity, right? You're going to provide them with wired internet connectivity and redundant connectivity. So you have different management, different security challenges with IoT gateways. This also applies really in any remote office situation, right? So it could be a company with multiple offices. It could be a retailer with multiple stores. If you think about, your local store, they're going to have some network equipment, right? And for that store, it could be to support their point of sale systems, to support their, their physical security, their alarm system. It could be to support the Wi-Fi they provide their customers. There's a number of reasons to have, as well as the sort of the office functions, the print server and supporting the laptops in the office that's in the back of the store. So all of that now would be for each and every retail establishment. So if you're a large retailer with thousands of stores, each and every one of those now is part of the near edge. But there's more to this near edge story, and that is what the telcos are doing, because the telcos, you think about the, the telephone companies, the telecommunications companies, they already have cell phone towers, right, which are now mini data centers in their own right. If you've ever seen a cell phone tower, it has this little building at the base. I don't know if you ever wondered what's in there. Well, it's like a little data center, right? It'll have racks of server equipment and the switching equipment, which is now all, high-tech servers. It basically boils down to that. So, and then telcos also have points of presence, and points of presence have been around for decades, or maybe even centuries. And these are nondescript buildings that every town has. I know the one we have here in my town is really, it's just a block away. It has, Verizon sign on it, but other than that, it's just a nondescript brick building. You have one in your town, or maybe multiple ones. And it used to be, this is where the local switching equipment was, and they'd have these big switching relays back, before before the internet hit. So they've been doing that for 150 years. Then it became the point of connectivity for the early telco provided internet. The ADSL had to be connected to a point of presence because it was location sensitive. And today, now what are they doing with these? Well, they have all of those traditional telco capabilities, but they're also building out internet infrastructure. So this is the near edge for the telcos. So we have what the telcos are doing with cell towers and points of presence. We have remote offices, we have retail establishments, and we have IoT gateways, which could be supporting any of these IoT use cases, whether it's factories or smart cities or other or video surveillance, really for any facility that requires video surveillance. So, so we have now these distinct notions of the edge, where the near edge would support the far edge, right? So if you have your IoT devices at the far edge, they may connect to an IoT gateway at the near edge, which may or may not be at a telco provided facility, right? So this is all part of the sort of the modern, what's happening to the modern internet.
Just to add to that, I think it's also what we've seen, and what the near edge also makes it very attractive for retailers. I think is the possibility to become again independent from the cloud that has centralized a lot of their function. It is still an ongoing transition to be clear, but it also, if you look at Walmart and Chick-fil-A and other like use cases, you see that having this like low latency micro private cloud running on site, this will become a big innovation factor, I think, for businesses to rethink how they want to change the experience or to improve the bottom line of their local business. So in some cases, it might be smart edge analytics and consolidation of data. And in other cases, it can be really hosting, being really becoming autonomous to the cloud link or to the network for the core business that they're running. So Walmart tries to build a so-called intelligent edge, the edge that runs like Microsoft workloads on the edge there, to have a super fast, super responsive service mesh for the local stores. And on the other hand, other retailers are using that to aggregate and correlate data before they actually send it then back to the cloud for a bigger analysis. Even enriching that data with local sensor data, or you have it here also on the slides with AI functions that can run locally.
Right, and that notion of the intelligent edge brings up this question about artificial intelligence, AI at the edge, and this is a very important trend as well, for the reasons that Moritz mentioned. Right, we want to have intelligent data processing, but also because we have multiple AI-based use cases, and in many cases it makes sense to run these at the edge. So now, why would that be? Well, why would you want to do AI at the edge as opposed to in the cloud or on premises? What is the advantage there? Well, the challenge here is that the bigger your data sets, the better the results of your AI. And the results of the AI are essentially inference, right? So you have the learning part of the story and you have the inference part of the story. Learning is the training where you take your raw data sets and you feed them into your AI, and it gets smart about coming up with answers, and the answers themselves are the inference, right? So the learning can be done wherever it is appropriate given your particular situation, but the inference is much more of a real-time kind of thing, right? You want to be able to draw the intelligent conclusions from your AI as needed. So because the trained machine learning leverages vast quantities of data, we have a data gravity issue. So data gravity essentially means that for very large data sets, it can be expensive and time consuming to move the data. So it makes more sense to move the compute capability to where the data are, as opposed to move the data to where your compute capability is. So instead of taking all of your IoT data, shipping it to the cloud for processing, you want to take your IoT data and process it at the edge so that you can gain your inferences from the AI at the edge as well. So a great example of this would be, say, video surveillance. So you have a secure facility, it's a military base, or a factory complex or something like that, where you have high levels of security requirements. Well, so you have a lot of these video cameras, but for a large facility you might have hundreds or thousands of them. So what do? You have a big team of security people are watching these camera feeds all day and all night, and that's hard to do, right? They miss things, things are going, hours of mind-numbing boredom, and on the off chance there's going to be some bad guy sneaking around. Well, what's happening today is the AI is able to not only detect, say, simple things like, there's motion where there shouldn't be, but actually AI can detect suspicious behavior. So even if you have surveillance where, let's say in an airport, where people are moving around all the time, you don't just want to say, here's a person moving around. That doesn't tell you anything useful. You want to say, here is a suspicious person, somebody behaving suspiciously. AI is now smart enough to do that. So you want to be able to do that at the edge, because you need the results right away, and the vast quantities of data, there's no need to send all that information to the cloud or a central location. You want to be able to process it at the edge to gain the inferences, which is this behavior over in this particular location at this time is suspicious, and so now we want to have somebody look at it or go out there and check it out. So that's a key example of when you would want to do AI at the edge.
Yeah, I mean, and I mean, it's similar. It's a very good example because it shows that you can use the decentralized data sets where you gather data and bring them as close as possible to your functions, and being it in a Kubernetes function, being it, like you said, an AI function that matches with deep learning some pictures against known labeled data sets, or again against a set of data that is not, it shouldn't even be pulled back or backhauled back from the cloud. But it also shows that data becomes transcendent where it actually is stored. And coming back again for where is the network parameter, I think the edge, the so-called intelligent edge, turned this whole concept around. So it's you bring compute power as close as possible where you gather data, where you want to process data, where you want to create a direct response, low latency where possible. And you upload or store data in the cloud that is that has been processed and needs to be processed in further tiers. But it also shows that the data privacy and security and encryption around this becomes a challenge, because it's not only data addressed where you were sure that your Azure or AWS or GCP platform or other provider had all the right ISO certifications, had the right SOC audits. You have to make sure that if you drive those kind of use cases, that the data and the calls and transit are encrypted, but also when you have something running on the edge nodes, that those edge nodes are hard enough and secured enough to actually being able to confidently use those functions.
Yeah, and this is becoming increasingly important as the intelligence on the edge increases, right? Because if the edge computing is just a simple routine processing, then if it's hacked, it's easier to detect. But if it's intelligent, then a smart hacker can compromise it in ways that require more sophisticated controls. So it's important to have the cybersecurity essentially keep up with the technology as the technology improves as well. And this is becoming modern battleground for cybersecurity, is the AI in the hands of the good guys trying to run to keep up with the AI in the hands of the bad guys, and that's sort of the trend today. So
yeah, I mean, from a business perspective, this becomes a real another layer of complexity. And then if we just come back to the title of the webinar, is again the question: how do you manage the sprawling edge? Because the sprawling edge doesn't necessarily mean that you not only that you have more devices on your network, but you also have more critical devices and more critical data dispersed and distributed from not only from the cloud, but also now again back to the edge.
absolutely. So we also I also talked about a couple of slides ago about the role the telcos are playing in building out the near edge with their cell towers and the points of presence. So the obvious question is, well, why do the telcos care? Is it simply because they are providing, they own the internet, essentially they own the backbones that run the internet, so they, as internet providers, that's why they're concerned? Well, there's actually more to it than that, and that is the 5G build out. So 5G, fifth generation mobile telephony technology, it's still largely in the future for us as consumers. It's going to take maybe 10 years to roll out completely, but the telcos are already hard at work. So in terms of the telcos, 5G is here, they're building it out. It's going to be coming in phases, but it's not in the future for them. It's already a thing. So what are they doing? Well, they are building out 5G at different parts of the 5G story at different places. So now 5G, you might think of 5G as being sort of the replacement for 4G, and we're used to 4G or 4G LTE as being how we get both phone and data connectivity on our mobile devices. But it's actually more than that. It's not just a replacement for 4G, but you can think of it as a replacement or a competitor to Wi-Fi, as well as a competitor to Bluetooth, but really in terms of your short range or medium range or long distance connectivity at the different frequencies. But for each of those, it brings new use cases to the story, right? So part of the challenge, though, is that it is many of these protocols are location sensitive, right? So you don't necessarily run all of 5G from cell towers the way we do 4G. So what the telcos are doing is they're rolling out new capabilities at the near edge to support 5G, to support a whole range of essentially future-facing business use cases. Although some of them are actually, in trials today. So there are stories, for example, largely in Korea, say South Korea's early adopter, for instance, bringing 5G to a stadium, where now we have sophisticated interactivity that goes beyond what today's mobile phones can do in the context of a stadium. So think of combining your mobile phone capability with Wi-Fi and then multiplying it by 10 for stadium participants who now have real-time interactivity with the signage in the stadium and across with each other. And there's a whole range of different possibilities. So there are many different protocols, and because many of these have location sensitivity, this is one of the main reasons that so much effort is going into the near edge. So Moritz, a moment ago, mentioned Kubernetes, and Kubernetes is container orchestration technology, and containers are a new part of how we're building cloud native architectures. And you might think, as IT infrastructure that is cloud native, Kubernetes really belongs in the cloud, potentially on premises, but in reality, you can run Kubernetes at the edge as well. And this is what a lot of the telcos are now experimenting with. It's still early days, you know, it's a new technology, but Kubernetes, as well as OpenStack, you know, private open source private cloud technology running at the edge. So in these small data centers and at the cell towers and the points of presence. And so there's a whole range of different capabilities. If you can bring all the power of the cloud to that near edge facility and then connect it via 5G to end users, there's immense capabilities that we've only just scratched the surface on. So it's really very exciting, but also opens up a whole range of challenges, you know, because everybody has to update their technology. We have new business models that require greater innovation, and we always have security and management challenges. And if anything, the 5G consortia who've driven the protocols, if anything, they've, you know, my sense is they've shortchanged security, right? They really should have done a better job with security than they have. And so that's going to continue to be an issue with 5G moving forward. So I don't know if that's what you're hearing as well, Moritz.
Yeah, so I think primarily 5G is a great new alternative to LTE and 4G connectivity at first. So I think that it will take a significant amount of time, like you said, to roll it out. The density of the cells is higher, so you need more masts for per cell to, if you want to achieve those multi-gigabit speeds that were advertised. And for our use cases that we see for customers, I think it means a much more agile way to create access. Reliable access for opening up new locations, opening up new offices, but also business centers. And it reduces to some extent. You can imagine that every building needing to have their own fiber access in the building. So the building access, you can now consolidate that to some extent via the 5G masts. But on the other hand, you still want to have, for your high fidelity access, you need proper fiber. But that being said, I think that 5G in combination with distributed like classless, or I would say a cloud independent storage or orchestration capabilities could be a very interesting, at least, platform for customers to experiment with their use case. You also mentioned earlier that many of those use cases are in experimental state, so there's no clear use case visible yet for like the silver bullet for each of those different verticals. But what it shows is that I think that this intelligent edge, and this is, by the way, also something that Microsoft, back even from Satya Nadella, is proclaiming, is that there's a big push towards intelligent edge to make use of those local resources. So not extending the network edge towards the cloud, but extending the cloud actually towards the network or the end user. So this is a fundamental paradigm shift that that already is kind of visible in some use cases, like the video surveillance case that you showed, or the Walmart micro private clouds. But it will be a new era that, if you go back to content delivery networks from the beginning of those slides, where you can actually then host functions on the edge that are relatively lean in terms of processing power, because they will always be augmented with cloud resources in the back, also intelligently routing loads to the cloud backends. This is part of the intelligent edge. But it also means that there are new use cases that we can think about, and it's actually the kind of disruptive creativity of each of those businesses to come up with a new use case. So, I mean, if you have told me 15, 20 years or 15 years ago that you can play any high-end game on any device, like what Gaikai and Google Stadia now enables with having compute and graphics GPU powers in the cloud, I would not have, I mean, argued that this would be possible. I would not have agreed to that. But now it's possible, and giving the speed of Moore's law and the ever accelerating exponential growth of compute power, it's a necessity that 5G might be the medium to transport it. It makes sense. It's mobile. It's wireless. But the combination of network access and close and proximity to the compute resources, that this will be key.
Yes, this is an important point, and I'm glad you emphasized this, that if we start thinking of especially the near edge, as a place that we can essentially do everything that we can do in the cloud, then we're extending this notion of cloud computing to the edge instead of the other way around. We're not just bringing the edge to the cloud, we're bringing the cloud to the edge. And we have to be a little careful with terminology that we don't start watering down terms like edge and cloud, because we don't want to just have everything mean everything, and then, what can we talk about now? But so we have to be a little more specific. And what we do at Intellix, we talk about cloud native computing as essentially being the architectural paradigm that brings the best architectural principles of the cloud to the entire IT infrastructure landscape. So horizontal scalability, software-defined configuration-based control, pay-as-you-go pricing, and all of these cloud-based benefits. Well, now we're bringing all of those cloud-based architectural principles wherever we need them, including the edge. And so that gives us the capabilities to do whatever sort of compute we need to, and we have the software-defined control over the network that we require to make all of this happen. And that actually brings us to our last slide, where we talk about how SD-WAN plays in this story. So SD-WAN, software-defined wide area network. The story with SD-WAN begins with the notion of a wide area network. WANs have been around for many years, and it's been a way for corporations in particular to connect their local area networks, their LANs, to remote networks. So it could be a headquarters connecting to a remote office or connecting to a retail establishment, and typically by purchasing or essentially leasing connectivity from a telco that is not on the internet, right? It's off the internet. Well, over the years, the internet, with broadband has gotten comparable in performance to the private networks like MPLS. That MPLS has been around for many years now. So now it's more of a question of picking the right protocol for the job and establishing ways to have failover or to combine them depending upon the needs. And this is now the role of SD-WAN. So the early, essentially first generation SD-WAN really had two basic goals, two basic capabilities. The first is to centralize management of remote network equipment, right? So if you are a retailer like Walmart and you have tens of thousands of stores and they all have equipment in their their data closets, you don't want to have somebody local at the store have to manage that stuff. So you want to centralize management at at your centralized IT function, even though the physical hardware is remote. And SD-WANs were invented largely to solve this problem. And then there's the question of selecting the right WAN protocol, right? You could be using MPLS, you could be using broadband, maybe there's another choice. And now you want to have intelligent selection, which might change on a moment's notice. It might, combine them. You may have a combination. For example, you might have one protocol to support your point of sale systems, another to provide customer Wi-Fi. You don't want to mix those together because it opens up vulnerabilities, and also it means that the kid, using YouTube in the waiting room can suck up the bandwidth that is used for corporate functionality. So you need to have all sorts of controls for that. So very important, and SD-WANs have been around for a number of years now because both of these core use cases are essential to corporate networks today. But this is changing, right? We're now moving into a new generation of SD-WAN technology where we're taking this notion of software defined, the SD part of the story, and saying, well, we need to have essentially a way of abstracting how we control the network overall from the physical network. So separate the control and data planes so that we can have policy-driven and intent-based control. So the business intent of how we want the network to behave is now something that the network automatically can support as part of the infrastructure. And we want to be able to abstract the endpoints, right? So endpoints could be everything from cloud, the cloud endpoint that has an API to the endpoint at the far edge, which could be your device or your IoT device, or it could be at the near edge, right? All of these are endpoints. So we have this vast proliferation of endpoints. So we want to have policy-driven control and management of those. And then we also want to have security in a trustless or zero trust environment where each endpoint is essentially responsible for its own security. So it's not that we don't have trust in a zero trust environment, it's that we don't assume that there is any trust. In the old days, we had perimeter-based security where we could assume once we've configured our firewalls that all the endpoints internal to the network are trusted, right? And that's a trusted environment. That's proven to be woefully inadequate. It really was inadequate starting in the early 90s once we let the internet in, right? Once we could get an email from outside, well, the cat was out of the bag and hackers were invited into the network. So we've realized for quite a long time that perimeter-based security is inadequate. So we take that understanding of that limitation of what firewalls just can't do for us and take it to now the modern context. Well, every endpoint, right, whether it's your mobile phone, whether it's that IoT device, whether it's IoT gateway, whether it's that server, that virtual server in some near edge server room, or it could be on the cloud, any of those are now under attack from bad actors, and thus every endpoint has to look out for its own security. So we have this whole new way of thinking about how we establish and manage security in a way that deals with the reality of the Internet of Things, reality of multiple different edges, and the reality essentially of modern corporate computing, which looks very, very different from the way it did just a mere 10 years ago.
From our side, I mean, it's perfect summary, because I think that if you looked at the SD-WAN 1.0, so to say, it was all about to make network equipment smarter, to route traffic better over MPLS and internet-based access lines, and I think that was far away from any like IoT or near edge or intelligent cloud edge discussions. So I think that it was the focus on primarily on the WAN and the network layer. And I think what has dramatically changed is that companies realize that the new default is that the clouds, the applications and the data and the users, they have left the corporate network, and they are residing in the cloud and are accessing applications directly in the cloud. And this also means that the software-defined WAN nowadays and also for future means that it's more an orchestration layer to connect users with applications in a way that it's programmable, it's highly scalable, it's based on the intent. So it's you have an application-centric view, you have an identity-centric view, you have a user and content-centric and data-centric view, where actually access is allowed and where it isn't. So it's rather using a blacklist model of the past, trying to keep the enemies out and the people in. You have now, it's more like an orchestrated whitelist model where you allow defined and known entities wherever they are actually to access them. And IoT Edge is also part of that, because in the end, the network becomes the critical infrastructure of any business or user. I mean, you can see it in your private life. If internet is down, nobody's happy. For an enterprise nowadays, this means this is a real business risk that has to be taken care of. And we're here to support our enterprise customers to confidently grow with their business, but with a zero compromise on security for that matter.
Very good. Well, I see that we only have about 5 minutes left, so we should probably get to some questions.
Sure.
Yeah, this is Kyle jumping back in. Jason and Maritz, great presentation, really great conversation there. So yeah, let's jump into a few questions. The first one we got is, what is data gravity? If you can just go into that a little deeper.
Well, data gravity, I mean, it's an interesting metaphor. You think of gravity and you think of a gravity well, like, you know, falling into a planet or into a star. But that metaphor was well chosen, right? Because if you're in a gravity well, right, you're here on Earth, it's very hard to get it to outer space, right? It takes a whole lot of money. It takes a big ass rocket, and it's complicated and expensive, and it's difficult to get out of the gravity well. And that's the same idea, is if we have vast quantities of data, it's difficult to move them and to deal with them. It's difficult to deal with them if we have to move them, right? So the last thing we want to do is have to put our data on the moon, right? Put it on a rocket, and now the rocket is very expensive and difficult to operate. So it's the same idea with data. So the bigger the data set, so you have a big data challenge, the more cost effective it becomes to move the compute capability to wherever the data are, right? So the cloud is good for this. If your data are in one place in the cloud, you might want to move the compute to where those data are. Your data are often on premises, and so now the question is, do you want to ship all the data to the cloud to process it? And for the purposes of our conversation, it was about data at the edge, right? Typically, because it's the data come from the Internet of Things. Well, now we want to push the processing to the edge as well. And that in large part is one of the main drivers for this definition of the near edge to support that far edge where the data come from.
No, thanks, Jason. That was a great analogy. I don't think I've heard it phrased quite like that. Yeah, but jumping into our second question we have here is, why is proximity to the user important for 5G?
Well, 5G, even though we think of it as being a replacement for 4G, so we think, well, as long as, you know, we can get near a cell tower, that's good enough. There are other protocols as well that are shorter distance. So the underlying physics is, you know, the lower the frequency, so it's the longer the wavelength, the shorter the distance that it goes. So, you know, Bluetooth is a shorter distance and Wi-Fi is longer, and then 4G is longer than that. And 5G now brings in a variety of different protocols that operate at different distances. But latency is in particular of particular concern. So here's a great example. If you had an autonomous vehicle, right? So it's a self-driving car, and you wanted to control it from the cloud, right? So anytime the car had to make a decision, it asks the cloud, you know, what should I turn left? Should I turn right? Should I stop? Well, a round trip to the cloud, if you're driving along at 60 miles an hour, is more than a car length, right? That latency is more than a car length. So by the time the cloud tells you to stop, you've already run over the kid, right? So obviously that's not good enough. So today we're putting all of the autonomous vehicle processing on the vehicle because the round trip to the cloud takes too long. Well, if we can reduce that, so the round trip to the cloud, which just now includes the edge, is you know, a few inches of the car movement instead of a whole car length. Well, now we can have much more intelligent control of autonomous vehicles because we've reduced the latency to the point that we can do a round trip in what essentially it's not 100% real time, but for practical purposes, it's as near to real time as we need to for the use case, in this case, the autonomous vehicle use case. So without 5G, we can't do it, right? We just do not have protocols that are fast enough. Well, with 5G, as long as we build out the edge-based infrastructure, then we're able to support real-time interactions at speeds that not just autonomous vehicles need, but any other business use case that requires that kind of real-time response.
If I may add, there is also, I mean, if you look at the strategies of AWS Outpost and Azure Stack, I think the dependency to central processing unit is apparent. So if you think about having SAP running in one centralized cloud or even in some cloud regions, but you're a company with 250 to 300, 500 sites or even more, And you could think of having those cloud like SAP instances in a microservice way running on the edge. So making it maybe not for the most critical sites, but for these sites, for your retail point of sales, making them super reliable and less dependent on the network itself. It would and increase customer speed and response would be amazing, I think. And if you think of like a standard point of sales office being dependent on a 3G or ADSL or even sometimes MPLS line, and you cannot process customer transactions or functions that you offer inside your business vanity, and you could have this localized and smartly detached and forwarded to the cloud where necessary. I think this is a way forward where we'll see a lot of activity soon.
Thanks. We are just about out of time, but I think it's worth running over just a little bit here. We had one person ask, what is a zero trust environment? If you can just kind of clarify that a little bit.
Well, the idea of a zero trust environment is that every endpoint, which could be on the server side, it could be on the device side, could be in the edge, has to look out for its own security. So if you think about how that would work in practice, it's not like we can have every device just sort of go off on its own. And, so how would we, change a policy across our organization if every device is looking out for itself? So we have to have a way of providing sufficient control and coordination, so establishing policies across the network that supports the ability for each endpoint to manage its own security. And it's a new way of thinking about security that doesn't rely upon a secure perimeter. So this is difficult to get your head around when you think about how reliant corporate security in particular has been on, say, firewalls, a perimeter-based solution. What if you didn't have firewalls? Or what if every endpoint had its own firewall? Then what would that mean for your network? And how does that differ from the reality of the fact that even if you have firewalls, hackers are getting through them all the time, right? So that's sort of the problem, right? Firewalls aren't doing their job. Things are getting worse, hackers are getting smarter, so we need to have a new way of thinking about this, and that zero trust or trustless security is what is sort of the general label we're applying to this.
Yeah, and I think zero trust was very made popular by Google, Google's Beyond Corp movement. So in principle, they said, we don't have a corporate WAN or corporate perimeter. We treat that every our devices or laptops is as being in the internet. I mean, this is like a similar case that we discussed in our previous conversation around IoT devices being added to trusted and untrusted in any networks, sitting side by side your company assets. And in the zero trust environment, you think that you assume or you plan that your architecture doesn't have a fixed parameter anymore. So the parameter becomes software defined. But this requires that every device participating in your software defined parameter then uses a centralized orchestration engine that actually approves every connection that is being made. But it also gets rid of all the appliances that are usually stacked at a kind of company edges, and it makes also use of the user's identity and also the user's device or the IoT device. So I think that zero trust with company enterprise users and devices combined also works pretty well also for IoT use cases, as soon as you have the identity and the orchestration around the devices under control. And along that side, this is also combined with micro-segmentation, where you actually only allow a certain application to talk to a certain cloud instance if this communication is mutually trusted and authenticated against some central user directory. From our point of view, secure SD-WAN is just the beginning of mixing highly available network resources, being very transport agnostic, providing application SLAs and guarantees, but at the same time, the network needs to be smart enough to support zero trust being part of that, or even orchestrating the zero trust access.
All right, thanks. That's all the time we have for today's webinar. I want to thank everyone for joining Managing and Securing the Sprawling Edge with SD-WAN, presented by Open Systems. Again, our presenters today were Jason Bloomberg, President at the analyst and advisory firm Intellex, and Mortiz Mann, Head of Product Management at Open Systems. Thank you all.